Right. So before we get into this, and we are getting into this, I need to address something. If you have a dog nearby, they are almost certainly watching you right now. That wet nose pressed slightly too close to your face, those eyes locked onto yours with an intensity that suggests you owe them a walk. And weirdly, scientifically, completely legitimately, looking back at them is making both of you fall a little bit more in love with each other. That's a real thing. We'll get to it. My name is Sam, and welcome to Dog Facts. And if you didn't arrive here expecting to leave mildly obsessed with the biological marvel that is the domestic dog, then strap in, because you're about to be. We're going to cover thousands of years of history. We're going to talk about noses that can detect a teaspoon of sugar dissolved in an Olympic swimming pool. We're going to talk about dogs that saved Hollywood studios from bankruptcy. Dogs that found the last survivor of the September 11th attacks. Dogs that can smell cancer before your doctor can find it. And dogs that, I promise this is real, align themselves with the Earth's magnetic field before they go to the toilet. Welcome to the most complete, most entertaining, and by a comfortable margin, the most dog-scented facts experience you'll have today. Let's go. Everything starts with a wolf. A very specific kind of wolf, actually. Not the snarling, terrifying kind standing at the edge of the firelight, trying to work out if your leg is edible. The kind that was, at the margins of their species, slightly less frightened of humans than the rest. Slightly calmer. Slightly more curious than defensive. Somewhere between 15,000 and 40,000 years ago, and researchers genuinely cannot agree on the exact figure, which drives them absolutely wild. Wolves and humans began a relationship that would change both species forever. The leading theory, backed up by genetic analysis and archaeological evidence scattered across Eurasia, is that certain wolves began edging closer to human campsites, drawn in by scraps of food, leftover bones, the warm glow of a fire that a wolf brain, stretched with hunger and cold, found increasingly hard to resist. Over time, the less aggressive individuals, the ones who didn't bolt when a human made eye contact, passed that slightly more relaxed temperament onto their offspring. Humans, meanwhile, found these semi-domesticated proto-dogs extraordinarily useful. They could hear things humans couldn't. Smell things humans couldn't. And if a threat was coming through the dark, they'd let you know about it before you had any chance of knowing yourself. The dog's scientific name, Canis lupus familiaris, actually contains the word for wolf, lupus, because that's what a dog is, not something that merely descended from wolves. Scientifically speaking, dogs are a subspecies of the gray wolf. They are, taxonomically, domesticated wolves who have, over tens of thousands of years, become extraordinarily attuned to us, which makes it all the more remarkable when you sit next to one on the sofa and they seem utterly unbothered by it. Now, there's a genuinely fascinating wrinkle in the origin story. Research published by scientists, including teams from Oxford University, suggests dogs may have been domesticated not once, but twice, independently, in both East Asia and Western Europe, before those two populations mingled as humans migrated across the planet. A 4,800-year-old dog skeleton, discovered at the Neolithic passage tomb of Newgrange in Ireland, carried genetic markers pointing to this dual origin, which means the global population of dogs today carries within their DNA the echoes of two separate ancient decisions, in two different parts of the world, that having a wolf around was actually pretty good company. As of right now, there are estimated to be between 700 and 900 million dogs on Earth. Around 80% of them are free-range, meaning strays, ferals, street dogs, and village dogs living largely outside of human homes. The remaining roughly 200 million odd are your pets, your companions, your couch hogs, and ball chasers. The United States alone accounts for around 80 million pet dogs spread across 42 million homes. That's a lot of muddy paw prints on a lot of kitchen floors. There are over 340 recognized dog breeds in the world. The American Kennel Club, which is the largest purebred registry in the United States, currently recognizes 202 of them, after adding 3 new breeds in January 2026. And if you're wondering which breed Americans love most right now, it is the French Bulldog, which knocked the Labrador Retriever off the top spot in 2022 after a staggering 31-year reign, and has held the #1 position ever since. Small dog, enormous ears, famously doesn't care what you think of it. Sounds about right. All right, you think you understand your dog's nose. You don't. Not yet. A dog's sense of smell is, depending on the source and the method used to test it, somewhere between 10,000 and 100,000 times more powerful than a human's. Let that sink in. If we're being specific about the mechanism, humans have approximately 5 million scent receptors in their nasal cavity. Dogs have around 300 million. The part of the brain dedicated to analyzing smells is, proportionally speaking, about 40 times larger in dogs than in us. When you walk into a room and smell coffee, your dog smells the individual components: the specific beans, the water temperature used, the cup it's in, the hands that touched it, the fact that you had toast this morning. Dogs also smell in stereo. Each nostril works independently, capturing scent information from slightly different angles, which allows a dog to triangulate exactly where a smell is coming from. A kind of 3-dimensional olfactory GPS system that no human engineer has yet come close to replicating artificially. And then there's this. Dogs don't just smell through their nose. They have a secondary scent organ called the Jacobson's organ, or the vomeronasal organ, situated on the roof of their mouth. When a dog licks its nose, it's not being adorable. Well, it is, but it's also picking up scent molecules from the air and transferring them to this secondary sensor. 2 systems, working simultaneously, processing a world of information that is completely invisible to us. There's also the fact that a dog's nose is wet for a functional reason. That thin layer of mucus on the surface traps airborne chemical particles and holds them for analysis. A dog that's running hot and panting, incidentally, loses up to 40% of its smelling capability, which is one reason working dogs are always kept hydrated and cool on the job. And just as no 2 human fingerprints are identical, no 2 dog nose prints are identical. The ridges and creases on a dog's nose form a completely unique pattern for each individual animal. Some kennel clubs have explored nose printing as an identification method, in the same way humans use fingerprints. Your dog's nose is a unique biological ID card that they are constantly pressing against your windows. A 2020 study from Sweden and Hungary added an extraordinary discovery on top of all this. Dogs' noses can detect radiated heat. The tip of a dog's nose, the rhinarium, stays several degrees cooler than the surrounding air temperature, and the nerve endings there are sensitive enough to detect the faint warmth of a small mammal's body from 1.5 meters away, even with no visual or scent information at all. Dogs can, in a meaningful sense, see heat with their noses. At this point, we should all simply accept that dogs are operating at a level of biological sophistication that puts our own olfactory system to absolute shame, and move on with the dignity we have left. While we're going through the sensory tour, let's talk ears. A dog has at least 18 individual muscles in each ear, which they use to swivel, tilt, raise, and independently rotate each ear. Think about that. You can't move your ears at all, and if you can, you're very proud of it at parties, and rightly so, because that's impressive for a human. Dogs are doing it involuntarily, constantly, building a three-dimensional sound map of everything around them. They can hear sound frequencies of up to roughly 65,000 hertz. Adult humans top out at around 20,000 hertz. Your dog can hear things that are, to your ears, literally silent. They can hear sounds from 4 times further away than you can. They knew you were coming home before you turned into your street. The eyes get a lot of unfair coverage. The popular myth that dogs see only in black and white is wrong. Dogs are not colorblind. They simply have a different range of color perception to ours. While humans have 3 types of color receptors in our eyes, dogs have 2, meaning they see the world in shades of blue and yellow, with reds and greens blending together into muddy, brownish tones. Their visual world is more limited in color palette, yes, but within their range, the colors are just as vivid and saturated as ours. It's the reason why if you throw a red ball on green grass, your dog is using their nose to find it rather than their eyes. Dogs also have a third eyelid. Called the nictitating membrane, it's tucked into the inner corner of the eye and slides across to protect and clean the eye's surface. Most of the time, you don't see it, but if a dog is very tired or unwell, it starts to show. And suddenly, you realize your dog has been hiding a secret eye this whole time, which feels unnecessarily dramatic of them, but here we are. And then there's the tapetum lucidum, a reflective membrane behind the retina that bounces light back through the eye a second time, essentially giving the photoreceptors a second chance to catch it. This is why your dog's eyes glow in low light and in photos. It's also why dogs can see so much better than us in near darkness. Their eyes are reusing light. It's extraordinarily efficient and also slightly uncanny. Dogs have between 319 and 321 bones in their body, the variation coming from tail length. Humans, for the record, have 206 and carry no tail-related wildcard. A Chihuahua and a Great Dane have approximately the same number of bones. They're just arranged in an aggressively different manner. And all dogs, regardless of size or breed, share the same number of permanent teeth. 42. Humans have 32. Dogs win again. One more biological note. Dogs regulate their body temperature almost entirely through panting and through the sweat glands located in their paw pads. There is a real phenomenon, confirmed by veterinary scientists, where a dog's paws can smell faintly of corn chips. This is not a malfunction. It's the combination of microorganisms naturally present on the paw combined with moisture from those sweat glands. Your dog's paws have their own little ecosystem. This is fine. Everything is fine. The domestic dog holds a biological record that no other domesticated species comes close to. No single animal shows greater variation in size, build, and appearance within a single species than the dog. A fully grown Chihuahua can weigh under 2 kilograms. The English Mastiff, officially the largest breed by weight, can top 155 kilograms. The tallest dog ever recorded was a Great Dane named Zeus, who measured 44 inches at the shoulder and could reach 7 feet 4 inches when standing on his hind legs. He died in 2014 and remains in the Guinness Book of World Records. The smallest dog ever recorded was also named Miracle Millie, a Chihuahua who weighed just 1 pound, less than a standard bag of crisps. And then there's speed. The greyhound is the fastest dog in the world and one of the fastest land animals on the planet, capable of reaching speeds between 43 and 45 miles per hour. For context, that's faster than a bicycle, faster than most horses at a canter, and would get them a speeding ticket in a school zone in most countries. Greyhounds achieve this through a running gait called the double suspension gallop, where all 4 feet leave the ground twice during each stride. Their feet are touching the ground only 25% of the time when running at full speed. The fastest dog ever officially recorded was a greyhound named Star Title, who hit 41.83 miles per hour on a straight track in New South Wales, Australia, in March 1994. At the endurance end, the Alaskan Malamute and the Siberian Husky can run for extraordinarily long distances without stopping, a trait built through thousands of years of sled pulling across Arctic terrain, where the ability to sustain effort across hundreds of miles was the difference between survival and not. You probably can't outrun your dog in a sprint. You definitely can't outlast a husky over a day's worth of running. These are facts that explain a lot about your average walk. Let's get into the mind of the dog for a moment, because it's more sophisticated than most people give it credit for. The average dog can learn over 100 words and gestures. That's not an estimate. It's been documented. Some individual dogs have pushed this significantly further. A border collie named Chaser, trained by psychologist John Pilley at Wofford College in South Carolina, learned the names of more than 1,000 individual objects, toys mostly, and could retrieve specific ones on command. More impressively, when shown a new object with an unfamiliar name, Chaser could identify it by a process of elimination. If she knew all the other objects in the room, the new one must be the one with the new name. Researchers called this fast mapping, the same cognitive process used by human children when learning language. Chaser could also count to 5 and had a documented understanding of categories and grammar. She was regularly referred to as the world's most scientifically tested dog, and she earned it. Dogs understand pointing. This is actually more remarkable than it sounds. Researchers at institutions, including the University of Sussex, found that untrained stray dogs, dogs with no obedience training whatsoever, could follow a human pointing gesture to locate a hidden object successfully about 80% of the time. Chimpanzees, our closest biological relatives, largely cannot do this without extensive training. Dogs, through thousands of years of living alongside us, have developed a near-instinctive ability to read human social cues that most other animals simply don't have. They have evolved to understand us. That's not metaphor. That's biology. Dogs also get jealous. A study from the University of California, San Diego found that when dogs watch their owners showing affection to a realistic animatronic stuffed dog, an object that looked like a dog and behaved like a dog, the real dogs snapped at it, pushed against it, and physically tried to insert themselves between the animatronic and their owner to reclaim their position. This is, behaviorally, jealousy. Dogs experience it. They act on it. And honestly, fair enough. On the subject of fairness, research has shown that dogs have a strong sense of it. In studies where dogs were asked to perform a task and rewarded inconsistently, where one dog got a treat and the other didn't, despite performing the same action, the unrewarded dog stopped cooperating. It noticed the inequality. It objected. The same behavioral pattern has been observed in wolves, suggesting this sense of fairness may be ancient, predating domestication. Right. Let's talk about some behaviors that look weird and are actually much weirder once you understand them. First, the pre-sleep circle. If you live with a dog, you've watched this ritual. Before lying down, your dog circles their chosen spot, sometimes twice, sometimes 8 times, sometimes enough circuits that you start to wonder if they're generating electricity. This behavior is a direct inheritance from their wild ancestors, for whom bed preparation was a matter of survival. Wolves would circle to flatten tall grass, scare off insects and snakes, check that the spot was level, and scan the perimeter one last time for predators. The circling also left a scent trail from the glands in their paw pads, marking the territory as occupied. Modern dogs do this on luxury memory foam beds in air-conditioned homes. The impulse remained long after the necessity vanished. It is, in the best possible way, a little echo of the Ice Age pressed into every bedtime routine. Then there's the compass behavior. In 2013, a team of researchers from the Czech University of Life Sciences and the University of Duisburg-Essen published a study in Frontiers in Zoology that had studied 70 dogs across 37 breeds over 2 years. Their finding: dogs prefer to align their bodies on a north-south axis when defecating, and they do this most consistently during periods when the Earth's magnetic field is stable, which happens for roughly 20% of any given day. When the magnetic field is fluctuating, the behavior disappears. This means dogs have a functioning internal magnetic compass. They are, under the right conditions, pausing before going to the toilet to check their orientation relative to the planet's magnetic poles. The fact that your dog takes forever on their walk now has a scientifically justifiable cosmic explanation. And then, the dreams. Dogs dream. This is confirmed, not speculated. Dogs, like humans, experience REM sleep, rapid eye movement sleep, the stage in which dreams are most likely to occur. Researchers at MIT found that the brainwave patterns in sleeping dogs during REM are almost identical to those of humans during the same sleep phase. When scientists temporarily deactivated the pons, the part of the brainstem that prevents mammals from physically acting out their dreams, sleeping dogs began to carry out full actions: sniffing, chasing, retrieving. They were running the dream. Puppies dream more frequently than adult dogs because their brains are processing enormous amounts of new information. Small dogs, statistically, dream more often. A toy poodle might have a new dream every 10 minutes, while a Labrador retriever tends to dream every 60 to 90 minutes, but for longer. Your dog is, right now, somewhere in a dream world doing exactly the kind of thing they love most. And that's lovely. If there were a Hall of Fame for dogs, and someone really should build one, the following animals would be first ballot inductees. Rin Tin Tin. In 1918, an American soldier named Lee Duncan found a German Shepherd puppy on a bombed-out battlefield in France. He named him Rin Tin Tin, brought him back to California, and the dog proceeded to star in 27 films and very plausibly save Warner Brothers Pictures from bankruptcy when the studio was struggling in the early 1920s. Rin Tin Tin's films were reliable hits at a time when the studio desperately needed them. His fame was so transformative that by 1925, German Shepherds had become the most popular dog breed in North America. He received a reported 10,000 fan letters per week. There is some genuine historical debate about whether he received the most votes in the first Academy Award for Best Actor, and that the Academy redirected the award to a human to avoid the embarrassment of giving cinema's highest honor to a dog. Rin Tin Tin died in 1932 in the arms of his neighbor, Jean Harlow, a Hollywood actress. Because of course he did. He was a movie star to the end. Balto. In January 1925, the town of Nome, Alaska, was struck by a diphtheria outbreak. The antitoxin serum was 674 miles away in Anchorage. Nome's port was frozen, its airport non-functional, and the only way to move the medicine was by dog sled relay across some of the most brutal winter terrain on the planet. 20 mushers and their teams formed a chain across the state, running through blizzard conditions and temperatures of -40 degrees. The final leg, 54 miles into Nome, was run by Musher Gunnar Kossin and his Siberian husky, Balto. They delivered the serum on February 2, 1925. Balto became an international hero. He appeared on the front page of newspapers across the world. A bronze statue was erected in Central Park in New York City the same year he completed the run, where it remains to this day. He lived until 1933, and when he died, his preserved body was displayed at the Cleveland Museum of Natural History, where it has stayed ever since. Hachiko. In 1924, a Japanese academic named Hidesaburo Ueno adopted an Akita puppy and named him Hachiko. Every day, Hachiko would walk to Shibuya Station in Tokyo to meet his owner returning from work. In May 1925, Ueno died of a stroke while at the university. He never came home. Hachiko returned to Shibuya Station the next day, and the day after that, and every single day for the next 9 years, 3 months, and 15 days, every day for the rest of his life. Hachiko returned to that exact spot at the exact time the train arrived, waiting for a man who would never step off it again. He was fed by commuters and station staff who recognized him. He became famous across Japan as a symbol of loyalty. When he died in 1935, a bronze statue was erected at Shibuya Station in his honor, where it is still the most famous meeting point in Tokyo. Loyalty doesn't get bigger than that. Tracker. On September 11, 2001, a Canadian police dog named Tracker and his handler James Symington drove overnight from Halifax, Nova Scotia to New York City to help in the rescue effort at Ground Zero. Among more than 300 search and rescue dogs working the site, Tracker found the last living survivor, a woman named Janelle Guzman, buried under concrete and steel for more than 26 hours. Tracker was later named by Time magazine as one of the 10 most heroic animals of all time. In 2009, BioArts International cloned Tracker from preserved DNA, creating 5 puppies. Symington raised the clones and trained them in search and rescue. Tracker's genetic line continues. And we should spare a moment for Pavlov's dogs, whose role in science was more significant than they could have possibly imagined. Russian physiologist Ivan Pavlov was studying canine digestion in the 1890s when he noticed something strange. His dogs had started salivating not when food arrived, but when the lab assistant who usually brought it walked into the room. Pavlov realized he had stumbled onto something fundamental about how animals, and by extension, how minds, learn through association. His subsequent experiments, associating neutral stimuli like metronomes with the arrival of food, led to the concept of classical conditioning, one of the foundational principles of psychology. Pavlov won the Nobel Prize in 1904, technically for his research on digestion, but his name has ever since been synonymous with the science of learned behavior. What's less often mentioned in textbooks is that Pavlov's dogs were later survivors of a catastrophic flood in 1924 that swept through his St. Petersburg laboratory, trapping them in their cages as water rose around them for hours. They survived. Their conditioning temporarily broke. Pavlov rebuilt it. The dogs shaped modern psychology. They deserve more credit than a passing reference in an intro lecture. The story of dogs detecting disease is one of the most genuinely astonishing developments in modern medical science, and it began, as many great discoveries do, by complete accident. In 1989, a letter was published in The Lancet, one of the world's most prestigious medical journals, describing a woman whose mixed-breed dog had become obsessed with a small lesion on her leg, repeatedly sniffing it, and even attempting to bite it off when she was wearing shorts. She visited a doctor. The lesion turned out to be a malignant melanoma. The dog had, without any training, been detecting the unique chemical signature of a cancerous growth. That letter opened a door that has since swung wide open. Cancer cells, and healthy cells affected by cancer, produce and release what are called volatile organic compounds, or VOCs. These are specific chemical molecules that escape the body through breath, sweat, urine, and skin. They exist in concentrations so extraordinarily small that no machine yet built can reliably detect them in clinical settings. Dogs can. Research conducted across multiple institutions and published in peer-reviewed journals has shown that trained dogs can detect breast cancer and lung cancer by sniffing breath samples, colorectal cancer from stool samples, bladder cancer from urine, and ovarian cancer from tissue. Some studies have reported accuracy rates of over 90%. A 2025 system that combined trained sniffer dogs with AI analysis of their behavioral responses showed an average sensitivity of 94% and specificity of 94.3%, comparable to established cancer screening methods. Beyond cancer, dogs have been trained to detect oncoming epileptic seizures, sometimes up to 45 minutes before they happen, allowing patients to find safety. They detect dangerous blood sugar drops in diabetics, alerting their owners in time to take action. And during the COVID-19 pandemic, trials in multiple countries showed that dogs trained on sweat samples from infected patients could identify active coronavirus infections with accuracy that surprised even the researchers running the studies. The nose that can identify a teaspoon of sugar in an Olympic swimming pool can apparently also identify the specific biochemical signature of a disease that had only been identified months earlier. Dogs are doing medical work that the entirety of human engineering has yet to replicate. Dogs are born blind and deaf. Their eyes and ear canals remain sealed for the first 2 weeks of life, during which time they are entirely dependent on their mothers. They come into the world without 2 of the 5 senses most central to their adult experience, and within a year, those same senses will be operating at a level that makes ours look like a rough draft. Dalmatian puppies are born completely white. The distinctive spots are the result of pigment-producing cells that activate only after birth, with small spots beginning to emerge within the first 2 to 3 weeks, darkening and spreading until the pattern is fully established by around 6 months. Every Dalmatian's pattern is unique. You will never see 2 Dalmatians with the same spots. Dogs, it turns out, have been scientifically tested and shown to behave with a form of unselfishness. An Australian study found that dogs exhibit what researchers called prosocial behavior. They will perform actions that benefit another dog, even at no reward to themselves. They cooperate. They share. These are not behaviors that were explicitly trained. They emerge from the social intelligence of an animal that has spent thousands of years navigating the complex webs of pack life and, later, human family life. The Moscow Metro's stray dog population has, over decades, learned to navigate the subway system. Individual dogs make commute routes, board at specific stations, ride to their preferred food-rich districts, and return. They have figured out that the city's underground railway is a useful tool, and they have adopted it. Transport researchers have studied them. The dogs, reportedly, are unbothered by the coverage. And finally, Paul McCartney, being Paul McCartney, included a dog whistle at the very end of the Beatles track, A Day in the Life, a sound recorded at 15 kilohertz, sitting right at the upper edge of what a human ear can catch, but well within the range of a dog's hearing. If you've ever played that record near a dog and noticed them tilt their head, you now know why. One of the most famous recording sessions in the history of music ended with a private message for dogs. The Beatles contained multitudes. So did dogs. So do dogs. 40,000 years of shared history, 2 independent domestication events, 300 million scent receptors, magnetic compasses in their biology, dreams in their sleep, love hormones firing every time they look at you. Cancer-detecting capabilities science is still learning to harness. Nobel Prize-winning contributions to psychology, war medals, Hollywood careers, 9 years of loyal waiting at a train station for someone who would never come. And still, somehow, miraculously, they're happy to see you when you walk through the door. Every single time. That's dogs. Thanks for watching.